Hi friends, welcome to all. In this video, we are going to configure CCNP ENCOR packet tracer, configure EtherChannel. Friends, please subscribe, share and like our channel. And also, if you wish to get any technical support, you can contact our team. All the details given in the description below. Back to our activity. Here we can see the objectives. In part 1, we will configure basic switch settings. Then we will configure an Ether channel with the Cisco PAgP, that is port aggregation protocol. Then configure an 802.380 LACP Ether channel, link aggregation control protocol. Then finally, we will configure a redundant Ether channel link. Here, three switches have just been installed, that is S1, S2, and S3. There are redundant uplinks between the switches. As configured, only one of these links can be used. Otherwise, a bridging loop might occur. Yes, you can see already some of the links are in blocked state. So, however, using only one link utilizes only half of the available bandwidth. Ether channel allows up to 8 redundant links to be bundled together into one logical link. Yes. That is what is Ether channel. So in this lab, we will configure port aggregation protocol that is called PAgP. It is a Cisco Ether channel protocol, Cisco proprietary protocol, and a link aggregation control protocol that is LACP, an IEEE 802.380 open standard version of Ether channel. Before beginning the configuration, review the Ether channel configuration guidelines and restrictions listed at the end of this activity. So here we can see they given some guidelines and restrictions. You can go through that. Around 11 instructions, guidelines and restrictions they given here. These guidelines are very important, and we should follow the guidelines and restrictions given here while configuring this Ether channel. Here I will just read all these guidelines and restrictions. Ether channel has some specific guidelines that must be followed in order to avoid configuration problems. All Ethernet interfaces support Ether channel up to a maximum of 8 interfaces, with no requirement that the interfaces be on the same interface module. Then all interfaces within an Ether channel must operate at the same speed and duplex. Then Ether channel links can function as either single VLAN access ports or as a trunk links between switches. All interfaces in a layer 2 Ether channel must be members of the same VLAN or be configured as trunks. If configured as trunk links, layer 2 Ether channel must have the same native VLAN and have the same VLANs allowed on both switches connected to the trunk. When configuring Ether channel links, all interfaces should be shut down prior to beginning the Ether channel configuration. When configuration is complete, the links can be re-enabled. After configuring the Ether channel, verify that all interfaces are in the up state. It is possible to configure an Ether channel as static or for it to use either PAgP or LACP to negotiate the Ether channel connection. The determination of how an Ether channel is set up is the value of the channel group number mode command. So valid values are active, LACP is enabled unconditionally, passive, and also LACP is enabled only if another LACP capable device is connected. So we can see active and passive for this LACP protocol. Then we have desirable, PAgP is enabled unconditionally. Then auto, PAgP is enabled only if another PAgP capable device is connected. So we can see these two commands, desirable and auto for this PAgP. And also we have a on EtherChannel is enabled, but without either LACP or PAgP. Then LAN ports scan from an EtherChannel using PAgP if the mode are compatible. Then compatible PAgP modes are, we can see desirable, or we can give desirable auto. If both interfaces are in auto mode, an EtherChannel cannot form. LAN ports can form an EtherChannel using LACP if the modes are compatible. So compatible LACP modes are active, passive. If both interfaces are in passive mode, an EtherChannel cannot form using LACP. Coming to the final point, channel group numbers are local to the individual switch. Although this activity uses the same channel group number on either end of the EtherChannel connection. It is not a requirement. Channel group 1 interface port channel 1 on one switch can form an EtherChannel with channel group 5 interface port channel 5 on another switch. But in this activity, we will configure this channel group same as on both sides for easiness. So we will see that one by one. So here they given the port channel table. We can see between S1 and S3, we will configure PAgP. Between S1 and S3, we can see the interfaces FS0/21 and FS0/22. Then between S1 and S2, we will configure LACP. Then between S2 and S3, we will configure LACP. So one side we will give active, the other side we will give passive. So part 1, configure basic switch settings. Assign each switch a host name according to the topology diagram, that is S1, S2 and S3. So just we will do that. Enable, configure terminal, then just we will set the host name S1. Coming to S2, enable, configure terminal, host name S2. On S3, enable, configure terminal, host name S3. Right. Before beginning the link aggregation between switches, verify the existing configuration of the ports that connect the switches to ensure that the ports will successfully join the Ether channels. Commands that provide information about the state of the switch ports include show interfaces, include Ethernet, show interface status, and show interfaces trunk. So we just will try on S1 in privilege exit mode. Show interfaces, you can filter it, include Ethernet. So here we can see all the ports in this switch. Line protocol is down, disabled. Also we can give a show interface status. We can see status, some of them are connected. And also we can see duplex and speed. So just to make sure that this duplex and speed is same on all the switches. Show interfaces trunk, we'll verify that also. Show interfaces trunk. So I think we need to configure the trunk. Configure all ports that are required for the Ether channel as static trunk ports. So they given a note. If the ports are configured with DTP, dynamic auto mode, and you do not set the mode of the ports to trunk, the links do not form trunks and remain access ports. The default mode on a 2960 series switch is for DTP to be enabled and set it to dynamic auto. DTP can be disabled on interfaces with the switch port negotiate command. So we will configure this static trunk on all the switches. Here on S1, we can see we used FA0/21 and 22, then G0/1 and G0/2. So we will configure static trunk on S1 first. Configure terminal. We will go to interface as a range FA0/21-22. Correct. Then G0/1-2. We will give a switch port mode trunk. Then here we have 23, 24, then G0/1, G0/2. On S2, interface as a range FA0/23 and 24, then G0/1 and 2. Switch port mode trunk. Then coming to S3, 21, 22, 23 and 24. Okay. Interface as a range FA0/21 till 24. Switch port mode trunk. Now we can verify this show interfaces trunk on 3 switches. Show interfaces trunk. So we can see those 4 ports are trunking. Then on S2, okay, it's trunking. Then on S3, show interfaces trunk. Okay, 21 till 24 are trunking. Coming to part 2, configure an Ether channel with the Cisco PAgP, that is port aggregation protocol. They given a note here. When configuring Ether channel, it is recommended to shut down the physical ports being grouped on both devices before configuring them into channel groups. Otherwise, Ether channel misconfig guard may place these ports into error disabled state. The ports and port channels can be re-enabled after Ether channel is configured. Yes. So make sure that you shut down those physical ports being grouped so that we can avoid this error. So configure port channel 1 between S1 and S3. The first Ether channel that is created for this activity aggregates ports FA0/21 and FA0/22 between S1 and S3. So here we can see that in the topology they already labeled here S1, and we can see those 2 ports FA0/21 and 22. Also the other end on S3 FA0/21 and FA0/22. So configure the ports on both switches as static trunk ports. So already we configured it. Now all the switches we configured it. And we verified it also, right? Use the show interfaces trunk command to ensure that you have an active trunk link for those 2 links. And the native VLAN on both the links is the same. Yes, we have seen that native VLAN, it is in a default VLAN, that is 1. Show interfaces trunk. Okay. Now on S1 and S3, add ports FA0/21 and FA0/22 to port channel 1 with the channel group 1 mode desirable command. That means on both sides we are going to give a desirable. So the mode desirable option enables the switch to actively negotiate to form a PAgP link. Note, interfaces must be shut down before adding them to the channel group. So here they given the command for S1 and S3. Okay, first we will do it on S1. Configure terminal interface as a range FA0/21-22. So we need to shut down it. That is very important. Okay. Then we will give channel group 1 mode desirable. Then we can activate the physical interfaces. No shutdown. Next, on the other side, on S3, configure terminal. We will go to interface as a range FA0/21 and 22. We will shut down it. Then we will create the channel group 1 mode desirable. Then we will activate it. No shutdown. Okay. So it shows red, then it will come back to amber, then it will be in green. The message creating a port channel interface, port channel 1, should appear on both switches when the channel group is configured. This interface designation will appear as PO1, that is port channel 1, in command output. So we already received that interface port channel 1 changed state to up. So we can see that PO1 is created. Okay. 21 and 22 is up. Interface port channel 1 changed state to up. And also it will show that creating a port channel interface port channel 1 just after giving that command. So here we can see that creating a port channel interface port channel 1. Okay. So next, configure the logical interface to become a trunk by first entering the interface port channel, then the channel number be given, that is 1. Then the switch port mode trunk command. Add this configuration to both switches. Okay, we will do that. So we need to go to that logical port interface PO1, that is called port channel 1. We can give PO1 switch port mode trunk. Then on S3, even I think without giving this command, it's already in trunking because we changed our physical port to trunking. So we can verify that before giving on S3. Do show interfaces trunk. Okay, here we can see port channel 1 is trunking. Yes, so we can see it's already trunking. But anyways, we will give that a command. Interface PO1 a switch port mode trunk. In step 2, verify port channel 1 status. Issue the show EtherChannel summary command on S1 and S3 to verify that EtherChannel is working on both switches. This command displays the type of EtherChannel, the ports utilized, and the port states. Command output is shown for S1. So they give shown here the output for this show EtherChannel summary on S1. So we will give that on S1. And show EtherChannel summary. So here we can see the summary. Group is 1, port channel. We created port channel 1, and we can see SU here. S is for layer 2 and U is in use. And we can see the protocol we given desirable, so it is PAgP. And here we can see the ports we aggregated. So it is FS0/21 and FS0/22. And here we can see that flag P. P means in port channel. So these are the ports we used to bundle as a port channel 1. Same way we can see it on S3. Show EtherChannel summary. Perfect. If the EtherChannel does not come up, shut down the physical interfaces on both ends of the EtherChannel and then bring them back up again. The show interfaces trunk and show spanning tree commands should show the port channel as one logical link. Yes. So that already we have seen that. Next, in part 3, we will configure an 802.3 AD LACP EtherChannel. Okay, that is in between S1 and S2. We are going to create this port channel 2. Configure port channel 2. In 2000, the IEEE released 802.3 AD, which is an open standard version of EtherChannel. It is commonly referred to as LACP. Using the previous commands, configure the link between S1 and S2 using ports G0/1 and G0/2 as an LACP EtherChannel. So we must use a different port channel number on S1 than 1 because already we used 1 port channel 1 for between S1 and S3. So we should not use the same channel number 1. We can use 2. They're given here 2. Because we already used that in the previous step. I mean this number 1. So to configure port channel 2 as LACP, use the interface configuration mode. Okay, we need to go to those interfaces G0/1 and G0/2. Then channel group 2 mode active command. So active mode indicates that the switch actively tries to negotiate that link as LACP as opposed to PAgP. The configuration of S1 is shown below. So we need to configure on both the switches S1 and S2. So here they given for the S1. So we will do it on S1 first. Configure terminal. We will go to interface as a range G0/1 and 2. So we will shut down it first. Then we will create the channel group 2 mode active. This is for LACP. We can see creating a port channel interface, port channel 2. Then we will activate it. Now shut down. Then we will go to interface port channel 2 and we will give a switch port mode trunk. Then on other side, on S2, enable configure terminal. We will go to interface G0/1 and 2. Okay, we should give a range because we are going to multiple interfaces. Interfaces as a range G0/1 and 2. We need to shut down it. Sorry, shut down. Then we will create the channel group 2 mode active. Okay, creating a port channel interface PO2. No shutdown. Again activated. I mean physical interfaces. Then we will go to interface PO2 and we'll give a switch port mode trunk. Okay, so it is in process. Then we will verify port channel 2 status. Use the show commands from part 1 step 2 to verify the status of port channel 2. Look for the protocol used by each port. Right, we can verify that. End show EtherChannel summary. So this is what we configured first, port channel 1 using PAgP. Now we configured LACP using these two physical ports G0/1 and G0/2, and we created port channel 2. So it is port channel in use, and we can see layer 2 in use. On the other side, show EtherChannel summary. Okay, port channel 2 LACP. Part 4, configure a redundant EtherChannel link. Configure port channel 3. There are various options for the channel group number mode command. So interface range FS0/23-24. Channel group 3 mode, then they given a question mark so that we can see all the possible modes. So we can see that here. Configure terminal. Interface as a range FS0/23 and 24. Then channel group 3 mode space then question mark. So we can see all those modes, active and active and passive for LACP. We can see enable LACP unconditionally using active, then passive is enable LACP only if LACP device is detected. Then we can see auto and disable for PAgP. So auto enable PAgP only if a PAgP device is detected, or disable enable PAgP unconditionally. And also we have this on. They are neither using LACP nor PAgP. Enable EtherChannel only. Okay, so on switch S2, add ports FS0/23 and 24 to port channel 3 with the channel group 3 mode passive. So here we are going to configure LACP with the passive mode. Okay, then other side we will configure active. Right. The passive option indicates that you want the switch to use LACP only if another LACP device is detected. So we will configure on the other side. So he will detect that S3 is actively participating in EtherChannel. So he will participate in this LACP. So statically configure port channel 3 as a trunk interface. So they given here for S2, we can do it. Okay, so it's a channel group 3 mode passive. You need to shut down it. Yes, that is important. So we can see FS0/23 and 24 are administratively down. Now we can create channel group 3 mode passive. Okay, port channel is created. Now no shutdown. Then we will go to interface PO3, port channel 3. Okay, interface PO3, and we will give a switch port mode trunk. Right. On S3, add ports FS0/23 and FS0/24 to port channel 3. Okay, so we will do it on S3 and make sure that the mode is active. The active option indicates that you want the switch to use LACP unconditionally. Statically configure port channel 3 as a trunk interface. Okay, we can do that on S3 also. Enable configure terminal interface as a range FS0/23 and 24. So shut down it. Channel group 3 mode active. Then no shutdown. Then we will go to interface port channel 3 switch port mode trunk. Perfect. So we need to wait some time so that this HTTP is in progress. So they will block any of the site to avoid the loop. Then step 2, verify port channel 3 status. Use the show commands from part 1, step 2 to verify the status of port channel 3. Look for the protocol used by each port. So we can verify that. And show EtherChannel summary. So we can see that 3, PO3, and we use these ports FS0/23 and 24. Protocol is LACP. Then on S3, and show EtherChannel summary. We can see port channel 3, protocol is LACP, and here we can see the physical ports bundled to create this port channel 3. So creating EtherChannel links does not prevent the spanning tree from detecting switching loops. View the spanning tree status of the active ports on S1 using show spanning tree active. Yeah, we can verify that. Show spanning tree active. So here we can see the details, spanning tree enabled protocol. So it's a port channel 1. We can see here port channel 2 is blocking alternate port. Yes, here we can see that. So whatever shows here in amber color, port channel 2. It is not showing like physical interface. Now it is port channel 2. So it is blocking here. And the port channel 1 is forwarding states. Yes. So port channel 2 is not operative because the spanning tree protocol placed some ports into blocking mode, because here we can see the loop between S1, S2 and S3, correct. So unfortunately those ports were the gigabit ports. In this topology, you can restore these ports by configuring S1 to be primary route for VLAN 1. You could also set the priority to 24576. So either we can give this command or we can give this command. So actually they are blocking the gigabit ports, right? So we can do that here. In global configuration mode, configure terminal, spanning tree, VLAN 1, root primary, or we can set the this priority. Okay. So now recalculating this STP. You may have to wait for STP to recalculate the tree topology. Yes. Yeah. Now this amber is changed. Here you can see the amber color. Press fast forward if necessary. Use the show spanning tree active command to verify that the gigabit ports are now in the forwarding states. Yes, we can verify that again. Show spanning tree active. So we can see now this bridge is the root, that is S1. And we can see both are in forwarding states, port channel 1 and port channel 2. Okay, perfect. So friends, that's all in this video. That is configuring EtherChannel. If you get any doubt, please feel free to contact us. So we will meet again with the next video. Thank you.